Thank you, Philly. All right. I saw from the poll that we have sort of a mixed previous knowledge about open source software. So I wanted to start with a bit of an explanation. What are we talking about? Free open source software. But basically, you're talking about code that is publicly available on the internet to fulfill some functions, usually also legally licensed, so you are allowed to use it. Sometimes you're required to return any modifications you've made back to the code base. So, basically it's about code bases that are fully available for anyone to build something with it on the internet. And I don't know how much a not software affiliated person knows about it, but it's really ubiquitous in all of software engineering. There's a lot of there's basically free open source software in every software product that you use. May not be at the top level with the entire product is open source, but modules and technologies and platforms that they use, it's a big thing. Let me conclude on that. Maybe I should add a bit why I am talking to you about this. Philly gave a great introduction about founders at unibw, and we are there's a lot of focus on the entrepreneurship startup side, but we're also what you would call a transfer institute. So one of our tasks is knowledge transfer. So the research that people do doesn't stay in silos. It flows around. It's being used for other research or by society at large to be economically useful, contribute to the improvement of technology. And one way to do this sort of task in the Transfer Institute is, of course, looking for startups. Say, do you want to make a business model out of your invention? But especially in the software side, I feel like that's not always possible. And I've always open source software has been ubiquitous in my academic history as a computer scientist, and so I feel like I should talk about it more, and I'll tell you why it's important for you. All right, so basically some motivations why open source is important. One angle is to look at it from the open science perspective. If you've heard about open science, if you haven't heard about open science, it's generally the process of removing all legal or technical obstacles from the process of science, not obstructing the flow of knowledge. I haven't found a really consistent definition. So the 6 methods that I've listed here, I've taken from openscienceasep.org. And we see some, pretty general, reasonable things like open methodology, open peer review, open educational resources. Well, I'm assuming most of you have had experience with publishing paper and publishing papers. So I personally haven't actually, but I'm often hearing that the peer review process is not entirely what you would describe as open and transparent. But that's not our main focus here, because as I said, computer scientist, software engineer, I guess I haven't settled really on a label for myself, is the technical aspects, open source and open data. For open data, you might also look at the NFDI, the National Research Data Infrastructure, which has been active for, I think, about 2 years. And I believe it's a charter of the European Open Science Cloud. It's sort of a German national implementation of a EU-wide program. And its mission is creating standardized data formats so data can be usefully exchanged between research projects. Or you might be looking at open access, and there I found, for example, the Budapest Open Access Initiative signed by over 1,000 institutes. And the general call is to make all scientific publications open access and to remove well, the paywall that a lot of publications are behind. Of course, our institutes have a lot of subscription, and through our library you can access most publications. But when a publication is behind a paywall, you limit the audience of people who could access your research, could learn from it, could improve upon it. So that's what's meant by an impediment to the flow, open flow of knowledge. And so, so I could bring that to open source, which is the focus of this talk. I guess maybe a very understandable example is if you are using a commercial software to create your research code. I'm assuming MATLAB will be a term for most of you. Then you are limiting the audience of your, well, limiting the audience of people who can reproduce your code to people who have access to this commercial software. And so there's, of course, a contrast to using open source code, which means that all people can run your code and use your software. Well, that is one aspect of it. The other aspect is, of course, publishing your code in the first place, so other people can run it and recreate your studies. And right here I'm sort of arguing, principles. It's in the interest of the spirit of science to do these things, but scientists are the only people who are of the opinion that open source is that working open source is very useful. So, for example, you might know that big tech companies open source a lot of their code. Here I've listed some examples. You might know Flutter and React, which are platforms for building applications for websites or mobile devices. TensorFlow and PyTorch are machine learning frameworks, and Kotlin is another application development platform. Well, an entire programming language if you're specific about it. And Kubernetes is about this is software for hosting scaled web solutions. But it's not about the specifics. It's the point. Okay, these are all published by very successful tech companies. Why do they share their code and allow others to use them without restrictions? Isn't that a disadvantage? And well, it seems like a lot of them have come to the decision, no, it's not actually. And the general motivations that I've heard about this were, first of all, you benefit from other people contributing back to your source code, which can be can generate new ideas. Besides, of course, sharing the effort of maintenance. There seems also an effect that I think is very interesting, that when the software is publicly available, people can, well, if you're not here to tweak it for every new use case people can update it themselves. And as a result, just making it open source can make your tech stay relevant longer, because a developer community has the opportunity to modify it for themselves, and that way you don't end up with, well, essentially stale products who have been outpaced by the progress of technology, and you've wasted the investment in building them. well, or at least you have a lower chance of that happening. Another point that's very interesting is, of course, if you start interacting with other developers on such technical level, you get a pool of talent that you could recruit and that you can recruit from. So with that in mind, if big tech is doing it, it can be that, well, I guess what I'm getting at, it's not an entirely altruistic decision. There is some inherently efficient way of working open source. It's an efficient way of developing software, is what I'm getting at. And if that's not enough, non-altruistic motivation, there's also cash to be had. I mean, you are probably all, or I shouldn't say you're all aware, but probably some of you are aware that there's plenty of NGOs who are funding open source projects, which are, well, which are not that well equipped in funds. So usually it's going to the most active, most well-established projects. But I wanted to highlight one program by the Open Knowledge Foundation, the Prototype Fund and the Prototype Fund Hardware, which is essentially incubator innovation program. Essentially, if you're submitting an idea for a piece of software that should be built in the public interest, then you can get a grant for up to 6 months to build a prototype of this. And the only condition is, of course, that it's public interest and, in consequence, published open source. So it's specifically for these kind of projects to get them going. The Prototype Fund Hardware has a similar idea, but it is for open hardware concepts. Another adjacent topic that I think I won't get into in the interest of time. But when we're talking about research funding one developer for 6 months, we're in sort of pitiful territory still. But what I've found extremely exciting is that in the last few years, governments have been getting involved, especially in the EU. I think it was the woman who led the Open Knowledge Foundation Prototype Fund, who is currently starting the Sovereign Tech Fund, which is a project of Sprint, which is the German Institute for Disruptive Innovation. And I didn't bring any hard numbers, unfortunately, but we're talking about different orders of magnitude of cash here. And they are already had a first round of funding some open source projects that they called, what was the name? Open Digital Based Technologies. For example, one grant was given for the maintenance of curl, which is a command line application that some of you may be familiar with. And of course, when we're talking about big funding, that we can't forget about the EU. And I've noticed the Next Generation Internet Initiative doing a lot in that regard, especially they have 2 programs right now in cooperation with NLNet. That is NGI Assure, which targets sort of internet technologies, new technologies that might transform the internet, or developing open source alternatives to commercial products. And then there's well, not that open source and commercial is a contradiction, but I hope you're getting what I'm saying. And then there's NGI Zero Entrust, which targets, I think, mostly security, cryptography related software. And those 2 funds are managed in cooperation with the NLNet Foundation, which is a Dutch non-profit, which is also active in the space. Right, I didn't mention it in the start. I wanted to do sort of intermittent questions at certain points, right? But now we talked a bit about the, I was just telling you a bit. Okay, this is why open source is a efficient thing to be doing, and it's on the rise. So you should be thinking about it more. Next, I'll be talking a bit about my experience of what are good practices in doing open source, doing FOSS, and then we'll have an interview with someone who has actual experience working on, well, research-related open source project that I've actually also worked on, which will be our guest speaker, Mark. But I suppose right now I'll open the floor for someone who has questions up to this point, maybe. I think I can't see all of your screens. Philly, is someone raising their hand right now?
No. No.
Right.
On chat, there are no questions, and I cannot see anyone raising their hand.
All right, then I'll continue.
Perfect.
Well, as I said, the next question was how to do FOSS well, which is to say, what are sort of practices that I've noticed in all the successful open source projects I'm doing, and I'm trying to, well, also apply sort of my own reasoning to why these are reasonable steps to take. And I'll take you sort of along a journey of, starting from an initial idea, coding initiative that can be open source, and how a successful, well, healthy open source project can develop from that. And maybe, of course, step zero of any step is probably if don't start an open source project if you don't have to. So that's, of course, if you've already, before you think about starting something like this, you should maybe do some research about, okay, is there already something in that space that is close enough to what I'm doing that could be repurposed, that I could or that I could build on, or that I could contribute to. But let's talk about you have had some novel research project that required a custom piece of software, and you want to follow open science principles, you want to be transparent, you want to be reproducible. So we have that one. So what should you think about when you're first releasing code? And I suppose, well, I'm sorry, by the way, fancy graphics stop here. So you'll I'll have to lead you through my interesting oration. First thing I think should be considered is topics of code quality, good documentation. If you're writing software that with the intention of it being reused, or you want to make it keep the option of it being reused, there are practices that you can follow. You can have complete documentation. You mention all the tools and all the environments that you've used in your application of the software, so someone else can recreate your software or recreate your application. They don't suddenly realize, oh, it's not running because you forgot to mention a module that you've installed. And that's also besides the idea of clean code, keeping the software in a readable, understandable fashion, thinking about well, cognitive complexity when you are designing your software modules, and trying to minimize complexity wherever possible. And that's maybe start sounding like, okay, so I have to go through a lot of effort to do this open source thing. Well, I'd say, yeah, that is effort to learn these skills, but there are also skills that generally make you a good software engineer. So I would encourage anyone to think about this in your own programming work if you do program. I'd say as a second remark, okay, you can once you've published your first code, that could be in a variety of ways. You could just upload a zip file of your code to your website, but if you're talking about adoption in let's say any sort of open source community, I think there's no way around Git. Short explanation about Git. Git is a versioning software. It tracks all the different iterations and versions that your software went through. And if you're familiar with versioning software, I believe, maybe I'm preaching to the choir here. I didn't feel like there was any sort of real alternative to Git. It's just achieved an extreme dominance in the programming market. Git an open source tool, by the way, so no problem with open science here. I suppose biggest competitor might be SVN. There's actually an SVN service hosted by the Rechenzentrum at our university, but not so much Git. I've heard talks in rumors that there was a GitLab instance to be hosted by the Rechenzentrum, which of course provides Git servers for anyone who needs it. But as I know, it hasn't materialized. But in practice, if you want to do open source, get on a Git server, and preferably an open Git repository that makes the whole process transparent. And now we've talked about a technical thing. I think it's also important to keep in mind the social aspects of open source. I think I'll mention some more technical stuff, but I believe what I'm talking about here is chiefly a social technology. It's essentially a way of developing software that revolves around a set of apologies, I'm a bit sick. Revolves around a set of practices that everyone follows, which increases the overall productivity and rate of innovation, I'd say. At least I believe that. But when we're talking on the social side, once you've published your code, and you are of course interested in other people using and working on your code to get these shared maintenance and crowdsourced innovation benefits. So just a few practices, I'd say. When you want to grow your open source project, get a decent website, something that succinctly explains what your software is doing and why people should use it, and try to explain it maybe in as few words as possible. Maybe be on YouTube, be on Twitter. I'd actually recommend, in this instance, for people to go onto Mastodon. I know maybe you've heard of it. It's generally teeny tiny social network, but I feel like academia and open source people are maybe the most drawn to it. So that's one possibility to engage with others. And another thing that I've seen a lot of open source projects do is to create some sort of chat server where the developers are around at least some times of the week, where you can quickly drop in and ask a question. Matrix is the most common service for this. Some people use Discord, which is a proprietary service, so there may be a bias against that in this community. So I'd say summarize it with be findable, be approachable, put yourself into the boots of someone who stumbled about on your project but doesn't know anything about it. How do you draw them in? And let's say, okay, let's say at this stage of your project, you've got a small community of people who occasionally work on your project, and a bunch of people who use it. you may run into issues related to sort of cooperative development. And yeah, it's how do I explain this? Essentially, what I'm telling you right now is why everyone is on GitHub. GitHub has introduced a bunch of features which are not exclusive to GitHub. There are open source alternatives, Audio or GitLab, for example, but it's ironically, this proprietary tool is sort of the dominant collaboration tool for open source projects, and it has a bunch of very interesting features. First, I'd say mention a pull request, which is I believe it used to originate just when a bunch of people were working on a shared Git project. People used to have their code on their own servers, where they had the rights to create updates and store their new code. And when you wanted to bring it into the central official Git repository, you would just write someone an email, hey, can you pull my source code from this branch bug fix XYZ that I talked to you about? That was used to be a pull request. Nowadays, it's let's say a central feature of these collaboration platforms that create when you want to contribute to someone's project in GitHub, you create a copy of that project, a fork, you make your modifications, and then you create a pull request, which is a sort of a ticket-like system of asking for someone to include your code. It's just what people used to do over email streamlined. Same as sort of a ticketing system to discuss bugs or new features. It also was very commonly used on these GitHub hosted projects or GitHub or alternatives. Yeah. And oh yeah, one final thing I wanted to mention is I suppose we're getting a bit technical here, is continuous integration tools. When we're talking about code quality, you start with sort of basic, write readable code, do good documentation. But a practice that's been pretty established at this point is automated testing. And sort of related to limping. Automated testing is basically including some code that allows the computer to automatically verify some base features of your code base haven't been broken. This integrates well with these productivity tools, these collaboration tools, that any code modification can automatically be checked for certain faults, and you get immediate feedback. So I'd say that's also something you should keep in mind when an open source project is taking off. But I say also subjectively, my personal experience with continuous integration, setting it up is always kind of a pain in the ass. So maybe don't get too hasty, but include it when it's useful. And just as a final note, when this is something that's really necessary when your project has gained a decent community of a lot of people who want to maybe influence the direction that the project is taking, you need to think about, okay, who decides what sort of, in what direction is this project being developed? What changes maybe go about the idea of the project and should be rejected? There's several ways to do this with sort of from an authoritative system who has the authorities to update code. A lot of projects have steering committees which approve big changes. Some communities go about it democratically and elect the people who have the authority over big decisions. But it's all some communities don't think it needs to be that complicated. If you're familiar with the term benevolent dictator for life, I think that's I believe it's been coined by the creator and maintainer of Python, which is he essentially has full authority about the official Python release. But it's I think it's interesting to think about how much this authority really means, because in practice, if leadership of an open source project goes against the majority will of a developer community, this can lead to a fracture of the project. Some people just leave and work on their own thing, or if a leadership keeps making unpopular decisions, the project can get abandoned. So it's an interesting topic, but I think in general it's a social exercise in cooperation to keep an open source project going. Advice that I've heard over and over again is to at some point put down a philosophy of where your project is going, what's its purpose. But there's also a mutual interest to keep the project going because everyone's invested in it. Right. Maybe one final note, because some of you who are interested in a founders webinar, maybe interested in entrepreneurship or a startup, founding a startup someday. So I wanted to mention this. Okay, these are all nice when you want to build, innovation network, and you want to build maybe a research community. But does this make sense if I have an idea that I have commercial ambitions for? And there's, of course, the idea that when you're giving up your proprietary code, you're sort of giving away an investment, and that you could at some point use to leverage a competitive advantage. I don't know, maybe I'll share an anecdote on this. I used to work at a large company who was involved in digital printing, and I was involved there was an internal tool that we were using, which was essentially used to compare pixel images. The printer generates a pixel image that matches the printing, the inkjets. And the idea was, to find bugs, sometimes you have to compare pixel images. And some guy told me that he made an innovation on this tool that is currently in the process of being patented. And the innovation was that whenever the tool detected a difference, so a pixel isn't identical to the sample, or a pixel differs from the correlating pixel in the sample, it would draw a bubble around it. So you could see it better. And I thought to myself, okay, what are we doing? Are we that unambitious that this is software innovation? I'd say if you're I think it's more realistic to make an impact with the software you're working on if you let these kinds of small innovations flow freely and let software get to the point where a bunch of these small innovations have created something really useful, and then maybe you can leverage something else into creating a startup. For example, we have some other IP in the hardware department, or sometimes you need no IP at all. Plenty of startups make a business of selling services based on an open source project because, if you want to use an open source project, maybe you want someone else who's really familiar with it to set it up. Why not the people who built it? So that's another way that a lot of open source based startups are being entrepreneurial without relying on software IP. Right. Let me check the time. Okay, running a bit late. I suppose maybe I'll bring in Mark right away, and maybe let's talk about well, technically Q&A should start now, but maybe we'll start the Q&A by talking to someone who's actually worked on a research open source project that I've actually also worked on. So I don't know, Mark, if you're ready, would you mind just telling us a bit about your work and about the project and how you're involved?
Yeah, sure. So thanks for the invitation. My name is Mark. I'm a PhD student at the Technical University of Munich in the Cyber-Physical Systems group of Professor Althoff. And we have this toolbox called Cora that Johann is currently sharing our GitHub repository. And it has been in development all the way back since 2006 when my professor started as his sort of code base for his own PhD thesis. And it kept on growing, and people kept on working on it, integrating new algorithms, just new code that was somehow adjacent to the already existing code base. And I'm currently the main administrator of this toolbox, both from a research perspective, since I'm also working on it as a researcher, using it and implementing my own algorithms in this toolbox, as well as dealing with whatever issues come up from the user perspective. That is both my colleagues that are using this toolbox and also people from other universities and all around the world that pop up writing emails saying there is a certain part of the functionality that's not working. Would you mind fixing this? And then we try to deal with that.
Very interesting. Yeah, I don't know, could you tell me more about sort of the spontaneous requests that you've been getting? Do you know sort of how people are finding your code base, and how do they are they only interested in using it, or do some people contribute as well?
So generally, I have just a vague instinct of how people come across this toolbox. Usually, it is referenced in quite a number of papers that use code from this toolbox, and I think it spreads mostly through the literature. So whenever people are looking for reachability algorithms, that's kind of the main thing of our toolbox. Then this Cora toolbox is referenced, and then they find the repository and can access the code this way. And the second way of kind of spreading the word of the existence of the toolbox is just by having collaborations, by having people know you and know what you do. And then they have this in the back of their minds. And whenever any kind of topic that includes functionality that we provide turns up, then this might be one way of trying to find a solution, is by knowing, okay, this toolbox exists and maybe I can use it to solve my own research question.
Very interesting. Yeah, it's as I imagine, definitely an asset for your chair to get some attention in this field of research. One thing I was curious about is, was there, I suppose you weren't around when the project started going open source, but do you know if there's sort of anyone ever questioned, the legal status of you developing open source code? Because I hear some people are unsure about that actually.
Mm-hmm. So you're absolutely right that this open source property of our toolbox clearly predates my tenure at the group. So I think the first actual release of the toolbox was in 2012. And from the stories that I've heard, it was just my professor who wanted this code base to be accessible to other people who were asking for it, who were interested in it. And then I think he sort of just cleaned it up so that it was a sort of stable version. And that was the first release in 2012. And I think from that point on, we were using the same license and he does have a sound knowledge base on licensing of software. We also have other toolboxes at our chair, and also he has been involved in some work regarding startups and the software that's used there. So he does have a lot of knowledge on that, and we've been running pretty smoothly with that license ever since, and also have no real intention of changing it.
Yeah, I think off the top of my mind, it says there you're using a GPL 3.0 license as a, or I happen to be aware of it. It's a copyleft license, so basically anyone's free to use it and distribute it. But I believe you are. I believe the main requirement is if you make changes, you are required to publish the changes, which is, of course, very convenient if you want people. If you want it to be sort of a collaborative effort.